Hello, in this new lesson, I want us to learn how to find an angle between two lines. But before we learn how to find that angle, can we first understand what angle are we exactly talking about? So let me show you. If we have two lines, say line 1 with, for example, coordinates like 1, 2 and 4, 5, and another line 2 with coordinates 1, 2 and 5, 1, and then we plot them. You see they intersect at a certain point. For example, these ones intersect at point 2, 1 or 1, 2. Then the angle we are talking about is this angle here. So in our case, if I was to show this angle here, this is the one shown by this green arc, and the value of that angle in our case is 57.9946, which we can round off to 58 maybe. But how did I get this angle? Now that we know the angle we are talking about, how did I get it? Let me show you. That angle between those two lines is given by this formula. Tan theta is equals to absolute value of the gradient of the first line minus the gradient of the second line divided by 1 plus the product of the first gradient and the second gradient. So in this case, these vertical bars are not for decoration. They mean if in any case you'll ever get tan theta which is negative, you need to ignore that negative sign and take it as positive. That's why I put them here. So in our case, to get that angle here, we need to calculate the gradient of the first line. We can call it the blue line, and then the gradient of the second line, which is the red line. So can we do that? So gradient of the first line, which I can say is M1, is given by change in y over change in x. If you don't know what is change in y over change in x, you can revert to my first lesson. You will understand how to calculate the gradient of a line. So here, I can say which is equals to y2 minus y1 divided by x2 minus x1. And I have all these values here. So I just need to replace them. So in my case, if, for example, I can say that line at point A, which was 1, 2, and point B, which was 4, 5, then this becomes my x1, this becomes my y1, this becomes x2, and this becomes y2. So the only thing I need to do is to replace them here. So to get that gradient m1, and just say y2, which was 5, minus y1, which was 2, divided by x2, which is 4, minus x1, which is 1, and the answer becomes 5 minus 2 is 3, and 4 minus 1 is also 3, so the gradient of line 1 is 1. How about the gradient of line 2, which we can call m2? Let me say I also have those points as A, and A is given by 1, 2. I'm picking them from here. And B is given by 5, 1 here. So the gradient, I apply the same formula like the first one. So it becomes, this is x1, this is y1, this is x2, this is y2. So the gradient of the second line, m2, is given by changing y over changing x, which is 1 minus y1 is 2 divided by x2, which is 5, minus x1, which is 1, which becomes 1 minus 2 is negative 1, 5 minus 1 is 4. So the gradient of that line becomes negative a quarter, which I can also write it like this, negative 0.25. Now that we know the gradient of line 1 was 1 and the gradient of line 2 was negative 0.25, can we now apply our formula to get tan theta, which is given by the absolute value of m1 minus m2 divided by 1 plus m1 multiplied by m2, which becomes, in this case, tan theta is given by m1 is 1 minus m2, which is negative 0.25 divided by 1 plus m1, which is 1 multiplied by m2, which is negative 0.25. So if I open the brackets, I get tan theta is equals to 1. Negative multiplied by negative is positive, so it becomes 1 plus 0.25 divided by 1. If I open the brackets here, 1 multiplied by negative 0.25 is negative 0.25. So I say it's minus 0.25. So the answer here becomes 1.25 divided by 1 minus 0.25 is 0.75. So the answer becomes, if we take our calculator and say 1.25 divided by 0.75, the answer becomes 1.6. So tan theta is 1.6. That is the answer for tan theta. But in our case, we don't want tan theta. We want the angle of this tan theta. So what I do, I'll go in my calculator and find tan inverse of this theta, which in our case is the tan inverse of 1.6. So if I find that tan inverse of 1.6, I'll get the angle. So can we try that? Go to the calculator and find 1.6, then I find the tan inverse of that, which becomes 57.994. I can say 9946, which I can just round off to 58 degrees. And if you check where, in our case, that is the angle between these two lines, it is 57.9946. If we round it off, it will be 58. Can we try another example? Question 1. Find the angle between the lines with the slopes. Slope, of course, means gradient, which is for the first line is 2, and for the second line is negative half. So this one we ended up the gradient, so we apply the formula direct, where tan theta is given by the absolute value of m1 minus m2 divided by 1 plus m1 multiplied by m2. So since we have all of them, I just put them direct. So tan theta is given by m1, which is 2, minus in brackets negative half. I can just write it as negative 0.5, then divided by 1 plus m1 m2, and m1 is 2 and m2 is negative half, like that. So I can say this one is 2 minus 0.5, it becomes 2.5 divided by 1. These two can cancel with this one, and then I remain with negative 1. Then now I have 1 minus 1 uh, which becomes 2.5 divided by 1 minus 1 is 0. So you have got tan as 2.5 divided by 0. Pay attention to what I do here. Look at my calculator. If I try to take 2.5 divided by 0, the answer becomes division by 0 is an error. So you cannot divide any number by 0. So in this case, if we don't get any value which is the numerator divided by 0, then it means that tan theta is undefined. And if that tan is undefined, this situation only occurs when the angle between the lines is 90 degrees only. So if you get the numerator is a number but the denominator is 0, such that you cannot divide the number by 0, then tan theta becomes undefined, and tan theta is undefined only when the angle between the lines is 90 degrees. Can you try question 2? But before you try question 2, let me show you question 3 so that you can have an idea on how to solve question 2. So in question 3, we are about to find the acute angle between two lines. I can call it, the first one is line 1, where it's given by 2y is equals to x plus 3. And then we have line 2, which has 3y plus x is equals to 7. So the first thing in this case is to change these equations of these lines to be in the format of equation of a straight line, which is given by y is equals to mx plus c, where m is the gradient, x and y are the coordinates, and c is the y-intercept. So in this case, if I was to change this one in this format, I would do it like this. I will divide every place by 2 by 2 by 2. So it will be y is equals to 1 over 2x plus 3 over 2. Then the second one is given by 3y plus x is equals to 7. So I would say first 3y is equals to negative x. I've just moved the x on the other side, plus 7. So I divide everywhere by 3. So now it becomes y is equals to negative 1 over 3x plus 7 over 3. And now I have the two equations in this format, where m is the gradient, x and y are the coordinates, and c is the y-intercept. If you don't understand the logic of all these values, you can review my lesson 2 and 3. You'll understand. So after we have learned this, the only next thing we need to do, since now we can pull out the gradient of the two lines direct, I just want to pick a gradient of each line, and gradient for line 1, which I can call m1, is half, and gradient for line 2, which I can call m2, is negative 1 over 3. So to get the angle between these two lines, I just need to apply tan theta is the absolute value of m1 minus m2 divided by 1 plus m1 m2, like that. So to get this, I just put the values direct. Since I have them, m1 is half minus 2 is negative 1 over 3, then divided by 1 plus, I already have m1, m2, so m1 is half, m2 is negative 1 over 3, So I can put them like this: half multiplied by negative 1 over 3, like that. So it becomes negative half minus that becomes a half plus 1 over 3, because negative multiplied by negative is positive, then divided by 1 minus negative half. Half multiplied by negative that is just negative 1 over 6 from root 1 over 6, right? Yes. So if I take the half aside, I can say half plus that. If I take half and that, their LCM will be 6. So 6 and divided by 2 is 3. Then multiplied by 1, of course, is 3. 6 divided by 3 is 2. Multiplied by 1 is 2. So it will be 5 over 6 for the numerator. And then for the denominator, this one, if I have a question like this one, minus 1 over 6, I can show you a trick and just change this one to 6 over 6, so that it becomes very easy to subtract. So I'll just say 6 over 6 minus 1 over 6, because 6 over 6, if I divide, I'll get 1. So it becomes 6 minus 1 is 5 over 6. So I divide the numerator with the denominator, and our numerator was 5 over 6, now divided by, again, 5 over 6, which is the same as saying this, 5 over 6 divided by 5 over 6, 5 here, 5 over 6, which is the same as saying 5 over 6 multiplied by 6 over 5. And in this case, I can divide that one by 1 by 5 by 5 and get 1, by 6 and get 1. So the answer becomes 1. But don't forget, this 1 is tan theta. So this one is tan theta. But in our case, we don't want tan theta. We want the tan inverse of theta, so that we can get the angle. So I'm going back to my calculator. And I take 1, then tan inverse of that 1, which is 45 degrees. So our angle is 45 degrees. So, bye for now. Let's meet in the next lesson.